In the first part of the experiment, you're going to have some hot metal, and your metal is going to be at 100 degrees. That is data B on your, because it's going to be in boiling water. Okay, and you'll also need to know the mass of your metal. A is your mass of your metal in grams. Okay, so you'll have your hot metal, and then we'll also have some water, and this is a coffee cup calorimeter with some water in it. You need to know the mass of the water in it, and the mass of the water is your C, and that is in grams. And then you also need to know the starting temperature before you put any hot metal in it. And that will be D in degrees Celsius. Okay, so now we know our mass and our temperature, our mass and our temperature. Then what we're going to do is dump the metal in. Put a lid on this and wait, and we will be stirring it as well. But anyway, wait, and the temperature will go up and up, and at some point it'll stop going up. It'll steady out, and when it steadies out, that is your T2, and that will be data point E. And from that, you should be able to calculate your specific heat for your metal. Okay, let's look at what we're going to do with the salt. Again, we're going to have our mass of our water. That will be F. And we will also have our initial temperature of the water. That's your H. Of course, in degrees C. Okay, and then you're going to have a vial of salt. And your salt has a mass of G. Okay, and we're going to assume that the T1 for the salt and the water are the same. So on this one, you dump the salt in, and it mixes around. You cover it, and you watch the temperature change. And your temperature will either go up or down, depending on if the reaction is endothermic or exothermic. But eventually the temperature will settle and you'll get a T2, and your T2 is data point I, and that will be in degrees C. And that should be enough information for you to calculate the heat of the reaction for the salt dissolving.